Hi, welcome to my channel. Today I would like to discuss with you an interesting topic, when to use Node.js and when not to use it. To answer that question, we must first know Node.js characteristics. Node.js is non-blocking asynchronous I/O. That means Node.js is a great choice for information systems applications that has a lot of select, insert, delete, and update operations. Node.js is a single thread but can handle many operations concurrently. Being single-thread allows Node.js to avoid overhead associated with multi-threaded environments. Multi-threaded environments suffer from when there is heavy concurrent requests, so you have to consider increasing hardware to provide more threads for handling those concurrent requests. It's challenging for Node.js to handle CPU-intensive operations. But why? Node.js has only single thread. So if your application tries to do a complex calculation, this calculation will run on that main thread that will block Node.js to handle other requests waiting to be handled. Node.js has execution stack, event queue, and event loop. Execution stack, when a script is running, functions are pushed into the execution stack, and JavaScript engine processes them one by one. Event queue, asynchronous operations like I/O operations or disk reading and writing or HTTP requests register callbacks in the event queue when they complete. The last one is event loop. The event loop checks the execution stack. If it's empty, the event loop takes the first callback from the event queue and pushes it into the stack for execution. Let's see how it works. Node.js code starts reading file1.txt and file2.txt using fs.read_file, which is an asynchronous function. Despite being single-threaded, Node.js does not wait for the file reading operations to complete. Instead, it initiates both reads and moves on, allowing other code to execute, like the final console.log. Once the file reading is done, the callbacks are pushed to the event queue. At the same time, event loop repeatedly checks the event queue for any ready callback function's response. And it takes them to be executed in the execution stack one by one. If you see here, event loop checks if the execution stack is empty. So once it's empty, it took the first read file callback function and it pushes it into the execution stack. So the event queue now has read file2.txt callback functions waiting to be served. So once the first callback completed, the event loop will take the second read file callback function and it push it into the execution stack. Now, why Node.js is a bad choice for CPU intensive tasks? Look at this example. In this Node.js application, you will see a heavy computation function, which is synchronous operation, and setTimeout function that is asynchronous operation. Node.js will execute setTime function in the execution stack. Node.js will execute setTimeout function in the execution stack, and it will not wait until completed. Its callback will be registered in the event queue. And Node.js will start handle the heavy computation function when the setTimeout callback function ready. It will wait in the event queue. However, at that point of time, the event loop will check the execution stack if it's empty. But the execution stack will be busy executing the complex logic of the heavy computation function. So the event loop will not be able to take the waiting callback function. So it's a block. That's why Node.js is not good choice for heavy operations, because it's a single threaded event loop will be blocked from handling the waiting callback functions, while a complex logic being handled in the main thread. So once the heavy computation function completed its execution, the event loop will take the setTime callback from event queue and it push it in the execution stack.
I hope you enjoyed the video. I hope you have learned something new today and interesting. If you would like to see more videos, please subscribe to my channel and press the like button. Thank you.